let's start talking about domain and range. We've talked a little bit about domain and range before, but let's just review. Remember, domain means all of the x values. So it's a set of possible values for the independent variable. Yeah, x, right? Range is a set of all possible values for the dependent variable. So that's all the y's. So if you're looking at, let's say, a coordinate like 3, 6, that would be domain, that would be the range. That's simple. But there's 5 methods of representing this, and that's what's the important point here. There's 5 different mathematical ways that you can actually represent it. Look at the first. The first one is words. Words are words. You're just going to describe what's going on. For example, words can be used to describe the values that are allowed. For example, the domain is the set of all real numbers between 0 and 10. So think about it. All the real numbers between 0 and 10. That means anything from 0 all the way up to 10 inclusive. That means including 0, including 10. That's how words work, okay? Very simple. Surprisingly enough, you're going to use the words in a sentence, or a sentence of words is going to be given to you. You'll have to interpret all the rest of these guys as we go. So let's get going. Let's start talking about number lines. Number lines you've been doing for years. It's a picture of a value that's allowed. For example, if you look at this 0 to 10 thing that's inclusive, there's the dot on 0, there's the dot on 10, and you shade between 0 and 10, and that's it. Unless it says something like, oh, let's look at all the numbers that are greater than 20. Then you put a dot on 20, and then you shade it, and then you say, oh, we have to shade the arrow as well, because it says greater than 20, that means all of the values that are going this way that are greater than 20, and that goes on forever and ever. A list. A list is real simple. For example, here's a relation here that gives you a whole bunch of interesting coordinate pairs. Da 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 da. So if you want domain and range, domain is very, very simply all of the x values. 0, 1, 3, 5, and the domain is listed here. If you wanted the range, then the range would be all of the y values. 0, 5, 7, and 7. 0, 5, 7, 7. There's your range. Okay, I'm going to skip over interval notation for a second, and I'm just going to go to our favorite, which is set notation. This is probably the most common one out of them all. Let's go talk about this. Let's talk about for example, the same thing we've been talking about here, all the numbers between 0 and 10 inclusive. How would you do this in terms of set notation? Well, you have to use certain parentheses or brackets to start with. The parentheses that you start with is this guy right here, those guys. Then you would say something like, since we're talking about the domain, we're going to use all of the x values. The x values that do what? Well, the x values such that. And the such that means here's the condition that goes along with the x values. Remember, you wanted all the values between 0 and 10. So, let's put all the values between 0 and 10, including 10 and including 0. So since x appears between the 0 and the 10, put the x between them. So you want all the values that are bigger and equal to 0, so bigger than and equal to 0, and all of the values that are less than and equal to 10, so less than and equal to 10. And there we go. And that's how you would represent it. But you would also tell me, what are we talking about? We're talking about real numbers, all the values. So you should actually include in this that, comma, x is a member of the real numbers. Okay, so watch again. Let's do this with range. If we said the statement, and here's the words, the statement says, read as follows. So I added more to this one, so don't read that part. I added more to it. If the statement reads as y is an element of the real number such that y is greater than 20. Okay, so here we go. Y such that y is greater than 20, but does not include 20. And it also is a set of the real numbers. So y belongs to R. That's how you do these. Now, that's a description of how to do all the notation so far except for interval notation. That's the one I want to look at, especially taking this and putting in intervals. What does this mean? There's a whole explanation that you can read here. You'd probably have to magnify it, but let me show you how it works. Real simple. When you have an equal sign, it's a square bracket. When it's not an equal sign, it's a curved bracket. So how do we describe all the numbers between 0 and 10? Watch this. Here's our starting number. It says equals to, so we're going to start and include 0. So that square bracket means to include 0. And then, comma, we're stopping at 10. So 10 is our next one, and we're stopping and including it. So that would be a square bracket. That's how easy interval notation is. Look at the range now. The range, which is all the values of y that are greater than 20. Okay, so are we including 20? No, we're not. So that's why we put a curve bracket on there. And the values greater than 20, well, what are we talking about? 30, 40, 50? How about 3,000? How about 62 billion? Well, of course. So in other words, any value greater than 20 is going to go all the way to infinity and all the way to positive infinity. But I got a question for you. Can we actually ever get to infinity? No, we can't. So guess what? We have to put a curve bracket on that. In the next couple podcasts, we're going to do all of these interval notations, the words. We're going to look at set notation. We're going to look at everything, okay? So this is a description, the type of notation that's used. You might want to, go back and watch this again so it burns into your brain. But I'm going to show you examples coming up right away in the next podcast, and you're going to get it no problem.